Since DAF Trucks built its first diesel engines for trucks and buses back in the early 50s, the Eindhoven-based PACCAR company has earned a sound reputation for the development and manufacturing of highly efficient and reliable diesel engines for trucks, buses and special applications. DAF was one of the first manufacturers to make use of turbocharging and was the industry leader with the introduction of turbo intercooling. DAF produces 9 and 13 litre engines in its entirely renewed engine assembly plant in Eindhoven. Both are 6-cylinder inline engines with electronic fuel injection, turbocharging and intercooling, providing DAF's highly successful CF and XF truck ranges with efficient and powerful power plants. After the implementation of the investment programs of the past few years, the DAF engine plant is now ranked amongst the most modern truck engine manufacturing facilities in the world. The engine plant covers an area of 375,000 square feet and currently produces 140 engines a day, with 3 shifts in machining and 2 in assembly. The engine factory has a logical and efficient layout, with clearly defined areas for cylinder head and fuel pump housing machining, pre-assembly of the cylinder head and cylinder head block machining, followed by the manufacturing area for camshafts and conrods. The next stages in the production process are the internal and external assembly, after which the engine goes to the hot test area, where every engine is tested in a highly modern facility. The next stages in the production floor are the first trim area, followed by the cleaning and paint process, and then the second trim area. Then the engine gearbox combination gets a final check and is leak tested before being delivered either to the truck factory or to external customers. Taking a closer look at the production process, this starts with the manufacturing of cylinder heads. After the pre-machined castings have been delivered to DAF, the first step in the production process is the deep hole drilling for the cylinder head bolts. In total, 6 dual spindle CNC machines are available for the parallel machining of 2 cylinder heads at the same time. A single spindle CNC installation is available for machining fuel pump housings. The cutting tools are preset in the tool room and identified with barcodes. 16 cylinder heads are machined in one fixture, 8 for the first operation and 8 for the second. Total machining time per fixture is 3.4 hours, covering a total of some 200 operations per setup. After machining, the cylinder heads are pre-assembled before they are transferred to the engine assembly area. Like the cylinder heads, the blocks are also supplied pre-machined. At the engine block machining line, a number of Heller MCP H300 CNC machines, 7 SW CNC installations, and 2 new Heller CNC 400 installations for processing the compact gravid iron block of the high-performance engines take care of drilling, milling, tapping and fine boring of the cylinder bores, as well as the crankshaft and camshaft bores. Finally, the blocks are interfluid washed and pre-assembled before moving to the internal assembly area. DAF's current engine generations have 2 camshafts, one for the engine and one for the UPEC fuel pump. Both of them are produced in the Eindhoven plant. Starting with the raw material, a straight bar of high-quality steel, the camshafts pass 6 main steps in the production process. First, the material is faced to length and centred at both ends. Then the shaft is turned with a Hyde lathe. Grooves are machined into the bar and bearing and cam surfaces are pre-machined. The next step is drilling a 14mm diameter hole through the total length of the shaft before moving onto the TC630 Werner CNC machines, where the centres of the keyway and the lubrication holes are machined. Finally, the cams are milled on a Heller CNC machine before being heat treated in Wild Barfield pit furnaces. After the heat treatment, the camshafts are straightened before the bearing surfaces and cams are ground. Finally, the grinding is inspected for burnt spots by means of etching, while control for cracks is also carried out by magnetic particle inspection. The camshaft is then cleaned and sent on to assembly. Moving on to the production of conrods, DAF currently has two machining lines, a traditional one for the conrods for the 9-litre engines and a highly modern line with a newly installed cracking process for the conrods for the 13-litre engines.
In the first step of the cracking operation, the rod that connects the crankshaft to the piston is positioned on the rotary table of the cracking machine. The big bore of the rod has to be split up to be able to fit over the outside diameter of the crankshaft. The table brings the rod to the first station where a laser beam makes a groove, ensuring that the rod will crack at the right spot. By cracking instead of sawing, the bore stays cylindrical because no material is lost, and the profile of the cracked surface forces the two halves to reposition to their original location. The next step in the process is the actual cracking. A hydraulic system pulls the two halves apart with a force of 40 metric tons. By cracking, we can reduce additional operations, such as machining location holes and installing pins to force the two halves into position. Now, the rod is taken to the station where the two parts are bolted together. Particles on the cracked surface that could contaminate the inside of the engine need to be removed. This is done by a combination of tightening, loosening, and shaking. Because the location holes are no longer needed, the two halves can be bolted together with 2 big bolts instead of 4 small ones. Finally, both halves get the same identification code, specifying they belong together. With this installation, we can crack 90 connecting rods per hour.
With all the parts produced, it's time to move on to the new internal assembly line, delivered by Bleichhardt of Germany and brought into operation in 2001. Improved ergonomics, increased quality and productivity, as well as the use of robots where appropriate, were the main objectives in the design of the new internal assembly line. This line consists of 25 carriers and 4 robotized workstations for critical torques. Assembly of all internal engine parts and the tightening of critical joints is carried out on the internal assembly line. The crankshaft is mounted, the pistons inserted, and main bearing caps and conrods are tightened to the correct torque by robotized torque-to-yield equipment. Timing gears and casing are installed, as well as the oil pump, the flywheel and the flywheel housing, before the engine is closed by mounting the oil sump and the cylinder head. Cycle time is 10 engines per hour, which gives a production capacity which currently is 80 engines per shift. Moving on to the next stage of the engine assembly brings us to the external assembly line, where the 30 carriers of the Motorail system take the engines from one station to the other, closely monitored by a supervisory control and data acquisition PC architecture. Process control, status and traceability is carried out by this SCADA system in combination with the manufacturing execution system. Also supplied by Bleichhardt of Germany, the external assembly line was brought into operation at the end of 2002 and produces 10 engines per hour. The nature of assembly work still requires people to do the actual mounting, but their work has become a lot more ergonomic and efficient, while at the same time quality has become almost man-independent. After externally assembly, the carrier takes the engine to the testing area, where 6 containerized test stations are available.
At the rig area, the engine is mounted on a test pallet and connected to the hydraulic, pneumatic, and electric interfaces on the pallet. After filling the engine with fuel, cooling fluid, and lubrication oil, the engine is transported to the test unit. In the docking phase, the pallet is connected to the test rig by an automated quick coupling system. After a few manual assists and a visual inspection, the engine is identified by scanning the production code into the system from the guidance book. The selection of the test protocol for this particular engine is done by the control system. By pushing the start button, a fully automated, man-independent test program is started. In the break-in phase, the engine is brought to its operation temperature in a controlled way to assure a good durability and low fuel and oil consumption during its operational life. In the define measure phase, the performance of the engine is tuned and defined to the load curve on torque and number of revolutions. While important engine parameters like fuel consumption, exhaust emission, oil pressure, and water temperature are measured. In the verification phase, the system checks if the engine's performance is within the specifications and if the test cycle was properly executed. An OK is only given when all parameters are within limits. Finally, all test data is stored. After cooling down, the engine is undocked from the test rig and sent to the D-rig area. At the D-rig area, the engine is dismounted from the pallet.
Time to move on to the first trim area. At this recently installed trimming line, 12 carriers take the engine along several workstations for mounting the clutch and gearbox and preparing for painting. The engine paint installation, installed in 2000 by EPV of Germany, uses a two-component waterborne grey primer for all engines. By making use of waterborne paint, the emission of volatile organic components has reduced from 2.6 kilograms per engine to only 0.1 kilograms per engine. First of all, the engines are hot water spray cleaned, after which they are turned and drained. After this phosphate treatment, the engines are dried, and inspection and additional masking is carried out before the engine is finished painted. For the painting, 2 booths are in place. The engines are forwarded automatically to trimming line 2, where the final engine dress takes place before the engine is shipped, so-called ready to drop, to truck assembly. In this area, components such as the cooling fan, additional external piping and harnesses, hoses and the gear lever are mounted. All in all, 20 carriers take the engines from one station to the other. Finally, the engine gearbox combination is leak tested and the gearbox is checked by running through all the gears. A certificate of compliance is generated automatically and the engine is ready to be installed in the truck.